This question's using statistics, so you've been given the data and it's the heights of different students from university, and there's 200 students in total. And you've been given the data in grouped data format, so each row in the table is grouped together. So this first one here, this is anything between 140, and it includes 140, all the way up to 160. So for the first question, we need to write down the mid-interval value, and the mid-interval value is just another way of saying the midpoint. So it's the middle of 140 and 160, and the middle point there is going to be 150, and it's meters tall for the heights of each student. And the second part is to calculate an estimate of the mean. So we can do this on the TI-84. So we're going to go to statistics and then on to edit. And the first thing we have to do is type in the information we were given. Because it's group data, we need to put in a midpoint value. So the first one is 150, and that's why the first question was asking it. The next one is 165, then we have 175, 185, and then the last one is 200. So it's just all of the midpoints for each of those groups. And then we can type in our frequency, so how many people were in each category. And then once we have that, we can go to statistics, we can move across to calculations, and we have one variable. So the variable is the heights. The first list tells us the data, and we've estimated that with our midpoint, and then we need to tell it where the frequency is, and the frequency is in list 2. So second function 2 gives me list 2, and then I'm going to calculate the answer. And you can see there that it's 176.3 to three significant figures, 176. So that would be your mean from the estimate of the grouped table in the data. So the next one is you've then been given the cumulative frequency graph for the data, and we need to use that to estimate the interquartile range. Now, we said at the start that there were 200 students at the university, so the median point, the middle, is 100, the lower quartile is 50, and the upper quartile is 175. Sorry, it's 150. And then the maximum is 200 and the minimum is 0. So you can see there where the quartiles lie. So from the quartile, we're just going to go across to the graph, and then we're going to read that value straight down. And you can see that first one is, I think it's 174, which is the median. Okay, so for the interquartile range, we want this point here, which if we pull down is 168. So 168. And then for the upper quartile, again, just going along to the curve and then coming down when we've reached that curve. And that's 183. So the interquartile range is 183 minus 168, and that gives us 15. So the interquartile range is 15. You do need to make sure you're reading off the data, so these values here, and not off the original kind of value of the data, this part here. So the part C, the last part of the question, says that a student in the data set is a height of 204, and we need to estimate whether or not they're an outlier. So for this one, we need to use the outlier formula, and the equation for an outlier is the upper quartile. So if they're 204, it looks like they're going to be in the kind of higher range of the data. So upper quartile plus the interquartile range times 1.5. So that's the equation to find if something is an outlier or not. We know that the upper quartile, this part here, this is our lower quartile, is 183. And we're going to add to that the interquartile range, which is 15 times 1.5. So if I type that into my calculator, I find that that gives me 205.5. So that means that any data above 205.5, so that's above kind of this value here, then that is an outlier. But our data was 204, so it just lies in the main set of the data, which is this part here, and therefore it's not an outlier. It would need to be bigger than 205.5 for it to be an outlier. Okay, so therefore he is not an outlier, and you would just write that down as your conclusion, that he is not an outlier.